Hello everyone. In this video we're going to look at how to use the different quotient. Now the different quotient it plays an important role in understanding the rate of change, the rate at which a function changes. So we will look at using the difference quotient to find the rate of change in this video. Okay, so the different quotient is f of x plus h minus f of x all divided by h. And that somewhat will end up looking familiar to you. But we're just going to look at problems and look at how to use the different difference quotient to find the average rate of change of a function. So in this first example here, we want to find and simplify the expression if f of x equals 2x plus 1. So we want to use the difference quotient, which is f of x plus h minus f of x, all divided by h. Now remember, with function notation, when you are evaluating a function, you replace x in the function with what is in the parentheses of this given expression here. All right, so let's start here and let's rewrite this function as bracket. Now I'm using this 2x plus 1 here, f of x plus h. I'm going to write 2, and then in the place of x, I'm going to place a set of parentheses, and then plus 1, and then minus f of x, so minus the function, so minus 2x plus 1, and then divided by h. Now, the f of x plus h part, again, when I evaluate the function of 2x plus 1 at x plus h, what I want to do is to replace everywhere that I see an x, I want to replace that x with x plus h. So instead of 2 times x plus 1, I'm going to have 2 times x plus h plus 1. So that's that f of x plus h part. And then minus f of x, well, the function f of x, we just need to rewrite that function as 2x plus 1. From here, we just want to simplify. So we'll use our algebra rules. We'll go through, distribute, and then combine like terms and simplify. So the first thing I want to do is to distribute the 2 to the x plus h. So now I have 2 times x plus 2 times h. The 1 was outside of the parentheses, so just plus 1. Now I want to distribute this minus as if it's negative 1. So that becomes minus 2x. Again, it just changes the sign, so minus 1 all over h. All right, so now we want to combine the like terms. So I have 2x, and then I have a minus 2x, so they will cancel each other out. Then I have 2h, so I don't have anything to combine that with, so I'll just write that down. Then I have the plus 1 and minus 1. They cancel each other out, all over h. So now that simplifies to be 2 times h divided by h. So since I have that factor of h in my numerator and my denominator, I can cancel those h's. That leaves me with 2. Okay, so again, the key here is to substitute in. So when I have f of x plus h, everywhere that I see an x in that function, I'll replace it with x plus h. And then minus f of x, so minus the function itself, all divided by h. And then from there, we will use our algebra rules to simplify. Okay, so let's look at another one. Okay, so here we have f of x equals x squared minus 4. We want to use the difference quotient to find the average rate of change of that function. Again, the difference quotient is f of x plus h minus f of x, all divided by h. All right, so same thing. We have the function of x squared minus 4. The first part that I'm looking at is this f of x plus h. So I'll use some brackets here. And instead of x squared, I'm going to write a set of parentheses squared minus 4. So here, instead of x squared minus 4, I'm replacing the x with x plus h. And then minus. All right, so we're minus f of x. So just subtract the function. So minus x squared minus 4. And then just all divided by h. All right, the x plus h squared. Now we can go back to our old algebra rule shortcut that said if we have a binomial squared, then we could quickly arrive at the answer by squaring the first term plus 2 times ab plus squaring b. So a squared plus 2 times ab, the first term and the second term, plus b squared. So I'm going to use that with the x plus h squared. Now your alternative there to multiplying that out, that x plus h squared, is to have x plus h times x plus h and use your FOIL or your distributive property. And you still get the same thing as what we would get if we used the shortcut. Okay, so I'm going to use the shorter version and just use the a plus b squared rule that we have and follow that pattern. So now that gives me x squared plus 2hx plus h squared when I multiply x plus h times x plus h. And then minus 4. Now I need to distribute this minus to each one of these. So it changes those signs so that positive x squared becomes minus x squared and that minus 4 becomes plus 4 all over h. Again, from there, we want to combine our like terms in the numerator. All right, so I have 1x squared, and then I have minus 1x squared. Those cancel each other out. I have 2hx. Don't have anything to combine that with, so I'll just bring it down. I have plus h squared. And then I have minus 4 and plus 4, so they cancel each other out. All divided by h. Now you see that both of my terms in my numerator has a factor of h. So I can simplify this a little farther by factoring out an h from my numerator. So if I divide each one of those terms by h, factor out an h, and divide each one of those terms by h, that gives me h times 2x plus h, all divided by h. And then the h's here would cancel out, and my final answer would be 2x plus h. So again, we substitute in, and then we use our algebra rules to simplify. Okay, let's take a look at one more problem. Okay, so in this one we have the function 2x squared minus x plus 3, and we want to use the difference quotient to find the average rate of change of the function. Okay, so again, f of x plus h I'm going to, I have 2 times x squared, so I'm going to write 2 parentheses squared everywhere that I see an x here. When I substitute the x plus h in when I'm working this part, everywhere that I see an x, I'm just going to place a set of parentheses because I know I need to replace those x's with x plus h. So I have 2 parentheses x squared minus, instead of minus x, it's going to be minus x plus h plus 3. Everywhere that I see an x for this f of x plus h, I need to replace the x from the function with x plus h. And then minus the original function. So minus 2x squared minus x plus 3. And all divided by h. All right, and then from here, we're just going to use our algebra techniques. So just like the previous problem, the x plus h squared, I will rewrite that by using that rule, a plus b squared, the first term squared, plus 2 times the terms, plus the last term squared. So 2 times h times x, plus x squared. Then next, I have to distribute the minus to the x plus h. So minus x, minus h, and then plus 3. Right here, I need to distribute this minus to each one of those terms. So minus 2x squared, minus minus makes plus x, and then minus 3. All divided by h. Okay, I will continue to use my algebra rules. I now need to distribute the 2 to clear those parentheses there. So now I have 2, sorry about that, I have 2 x squared plus 4hx plus, that should be an h squared, sorry about that. So plus 2h squared. And then minus x minus h plus 3 minus 2x squared. So I'm just rewriting everything else from that numerator. Now I will combine my like terms. So I have a 2x squared and a minus 2x squared, so they will cancel each other out. This is the only hx term that I have, so I will rewrite the 4hx. This is the only h squared term that I have, so I will rewrite the h squared, 2h squared. Then I have minus x and plus x, so they will cancel out. This is the only h term that I have, so I will rewrite that, minus h. Then I have plus 3 and minus 3, so they cancel each other out, all divided by h. Now, just like the last problem, all 3 of my terms have h, so I'm going to factor out an h and simplify. Now here, when I factor out an h from h divided by h, anything divided by itself is 1. H squared divided by h leaves me with an h there with a 2. And then I just cancel those h's, and my final answer, 4x plus 2h minus 1. Alrighty, I hope you found that video to be helpful. Thank you.